welcome back to another video with It's Dr. Dan, and today we're going to look further into introductory chemistry, specifically math skills to help you ace chemistry. This video we're going to be looking at dimensional analysis, which is a follow-up video to my unit conversion video, so it helps you be able to see a lot tougher problems that you're going to commonly come across, whether it's at the very beginning unit conversions or when you get to stoichiometry. This is one of the most fundamental skills that you can have for chemistry, physics, even engineering classes that you'll come across. So for this particular one, the whole idea with dimensional analysis is that it's a mathematical method to convert measured units into units needed to answer problems, which is a little bit of a mouthful, but it comes down to trying to answer a lot of word problems, which when we come across those, they can be really overwhelming when you see them. You can freeze up, you see all these words, you don't know how to find important pieces of information, possibly. And a lot of that comes from middle school and high school, where maybe you were never coming across all the skills to do that. Or maybe you have, and that's even better. But if you haven't, I'm going to go through a lot of those tips to show you how can you go through a word problem? How do you decipher it? So that way you can find the conversion factors needed to answer these problems, which all a conversion factor is a ratio or a relationship that's being hidden in a word problem. So you're going to be looking for numbers, little keywords that I'm going to show you look for to give you all those little tips and hints to be able to do dimensional analysis. So just look at the little preview, like what does that exactly mean when it comes to dimensional analysis? Well, we're going to be looking at just understanding simple fractions, right? We set up before in unit conversions was we set up a t-table like the one at the bottom of the screen, putting it away, like the one right here. So you always write down your different units you were given and what you desire. So if I'm given A and I desire C, I might have a couple of relationships that can get me there, whether it's through prefixes, US to metric conversions, maybe density, maybe even something that's given to you in a problem through maybe medical dosages. There's all kinds of things that you can come across. So how does this exactly work? Well, let's say if I'm given A, you always try to start with a number by itself. Then what we are going to do is cancel out those units, right? When they are opposites of each other, they can cancel. So opposites cancel each other out. And that is the key thing that we're always looking for, canceling. So when those cancels, right, being that A is equivalent to B, we can write that relationship. And we can also continue to write the relationship that B is equivalent to C. So what happens here is unit cancellation. A units would cancel A units, right? And that's what the highlighting here represents. And then the same thing here is that, okay, B units cancel out B units. And then that would leave us only with C. And that's the key. We're trying to cancel all of our different units as we're going through these problems. So we're going to go through a bunch of different tips and a bunch of examples in this video, and I hope that this helps. All right, let's get into it. Let's go through tips on how to decipher word problems. So starting here, whenever you see a word problem, it can feel like an extremely big puzzle, and it can be extremely confusing for a lot of new chemistry students. But the thing is, that's all it is a puzzle, meaning there's only one way that it can fit together. The pieces fit a specific way, meaning that our units are going to cancel a specific way. So when we are going through these, a few tips, we want to read the problems slowly. Every single word could hold a clue. So we want to be always looking through our little magnifying glass to find that clue. Try to read the problem multiple times if you have to. There's sometimes on exam, yes, there's a time limit, but when you're doing your homework or maybe if you have a quiz that's not timed, spend that time to learn how to do problems. It's a study method. The more you do, the easier it will get. It just takes practice. We need to practice anything, right? It's like I tell students all the time, if you played a sport or did an instrument, or maybe if you game, or if you do really any hobby, when you first did it, you probably were not as good at it first. And that's normal, right? We're human, we learn. So as you got better, you improved. It's the same thing in chem. It takes time. And that's really discouraging. It does take time, but that's with any subject. That's the idea of learning, right? The more you do it, the better you will get. So trust me, it will get better. So when you read it multiple times, what you need to do is define your givens. So what information is in the problem that you have. So numbers that you already start with. Then write your desired, which means what are you trying to find? It's usually a unit or a specific answer that will be set out in the problem. The last thing is you want to look for conversion factors, but for a lot of us, how? How do we do that? Well, there's going to be keywords we're going to be looking for. And with those keywords, the whole idea here is that it's going to help you let the units guide your thinking, meaning they need to cancel out. So top and bottom of these fractions, they cancel. So we need to try to map out a path for ourselves. And that's what we're going to be doing as we go through these problems. So let's take a look at some of the different terms that we will come across in these problems that can be a hint for your conversion factors. Okay, so when we want to see the world through conversion factors, there are giveaway phrases in a lot of these problems. So think of some things you come in your everyday life. If I ask you, okay, the following phrases, if you see in each, well, if I ask you for $1 and I ask you to make change, well, one thing that you could do is, oh, right, there's 100 pennies in each dollar. Well, knowing that, that is a conversion term that we can write for ourselves. So if you have 100 pennies in a dollar, we can define that conversion term, right? And you can either write that on top or bottom, depending on how you need to do that. If I ask you, how many days are there in a week? And right away, you're like, 7, of course. Well, you just define a conversion term without me doing anything. It's second nature because you've practiced it your entire life. So per, if you see something per something, that's telling you another one. So 7 days a week, we can define that as a fraction for ourselves, 7 days for every week. And you can flip it, right? If you need to, you can do it one way or the other, depending on how you need your units to cancel. If you see in every, well, all right, if I ask you how many months are in every year, well, there's 12 months in every year. If I ask, we can even define a term, right? So if I say there's 2,000 nails in every barn that's being built, that's defining your own term. It doesn't have to be this preset thing. You can define it. Any problem can define it however you need. Or if I ask you for recipes, right? Recipes are ratios, whether you need 1 cup of milk in this recipe. So you could say, all right, well, 1 cup of milk in, oh, I spelled milk wrong, in the recipe, right? That could be a conversion term. Or if I say 12 eggs in a dozen is a conversion term. All of these can be defined using these keywords. So write them down for yourself. Try to train your brain to finding them. They will help you. So there's 3 examples that we have in this video for you. We'll go through them. We're going to find all the key information. So find our givens, find our desireds, and we're going to find the unit conversions. So feel free to spend that time and pause when I read through the problem before I start solving it all, or you can just watch it, but try to see if you can do it too. Try to work along with me, and it will help you learn it. All right. So let's go on to our first problem. Our first problem of the video. So for this problem, what we are asking is how many minutes will it take to drive to Los Angeles from San Francisco? If an average speed of 72 miles per hour is maintained, the distance between the 2 cities is 405 miles. You're like, wait, what? I thought this was chemistry. Well, being able to read a word problem is still chemistry. Even when we do chemical equations later, we need to be able to find the key piece of information. So let's go through it. So I read that fast. So spend the time to read it to yourself slowly if needed. So the first sentence, how many minutes? That's your desired right there. How many minutes? So what we're going to do is we're going to highlight that. And we're going to write down here our desired. So desired is minutes. Okay, so it's in the first line. It's not always in the last line. Sometimes it's earlier, or it's earlier than that. All right, and it's asking from LA to San Francisco. That doesn't matter, right? That's just information. And a lot of these problems, it just gives you information to distract you. And that's something that's very common, especially in standardized tests. If you're a nursing student and you might have to take the TEAS test one day, very common. They might give you a different test that will distract you. So, and then it says, if you have an average speed of 72 miles per hour, all right, that's a conversion term. We can see the word per here, okay, which meant that, all right, well, I have 72 miles for every hour. That is a conversion for ourselves that we can define. So when we go through that, we can write 72 miles per hour, and then we have a ratio, and that can be flipped. Don't forget that, right? So we can also write 1 hour over 72 miles. As we continue to read the problem, it says the distance between the city is 405 miles. So we'll write that down too. So we also have 405 miles in the problem. So we're looking for all these little details that we have here. They will help us find it. So we need to see what is our commonality here. What do we have? Well, we want minutes. We have a time factor, which is hours. That's going to be our bridge there. So let's also set up the problem for ourselves. With all these, right, we will set this up as a t-table for ourselves because it shows fractions. It makes it a lot easier to keep yourself organized. Now, in these problems, we are given two different types of things that we can start with. We have conversion factors, which are these fractions up here. And then we also have a term by itself. If you have it, which most of these word problems you will, you always want to start with the term by itself. And I can't say that enough. Start with the term by itself. The reason is because you can't flip it easily, right? It's something that, sure, you could do it at the end of the problem, but at the beginning, it has to be in the numerator, cancel out units in all these problems. So if you have one, try to always start with the term by itself. It should lead to the correct answer as long as you cancel your units correctly. So, okay, we have 405 miles. Now, how do we cancel out miles? Well, I had two different terms up top that I could use. I have the one on the left, and then I have the one on the right. And both these are like puzzle pieces that you can fit into your puzzle a very specific way because units, right? They need to be opposite of each other to cancel, right? They need to be opposite. So in this case, if I have miles on top in my t-table, we also need miles on the bottom. So we'll write 72 miles per hour, and that will cancel, right? So you can see how they're opposites. Opposites always cancel, and we'll highlight it so that we can show how that's canceling, right? Opposites cancel each other out, and that's the ultimate thing, right? When we see these opposite units, they will cancel each other. So now we have hours. How do we get to minutes? Well, how many minutes are in an hour? You look at the timer all the time, right? When you're in class, you're like, oh my God, time's not going fast enough. So, but 60 minutes is in 1 hour. So how do you cancel out an hour? With another hour. So we'd write 1 hour on the bottom, and then we'll write 60 minutes on top. And then we can see, all right, well, once again, my units canceling. Fantastic. This is great. Now we have our final unit, which is what we wanted. We wanted minutes, so we can give a little check to make sure, okay, we're good. So now we can do the math. So when you're doing these, remember, each one of these is like a little fraction. Each of these little blocks that are here is like a fraction. So what we're doing is we'll take that 405, divide it by 72, it equals, times by 60, hit equal on your calculator. Now, when you get that answer, you're going to get 337.5 minutes. Now, is that the correct answer? The quick answer is no. So we need to round it. Sig figs matter because these are revolving around measurement. Measurement is key in science. So being that we had 405 miles and 72 miles per hour, those are measurements, right? You look at your speed gauge. You do that with a speedometer. That is a measurement tool. So how many sig figs do we have? We have 2 sig figs, and then we measure the distance, whether it's with your GPS or a map. That is 3 sig figs. Those are measurements. So what was the lower of the two, because it's all multiplication division, would be 2. So when we round this to 2 sig figs, it would be 340 minutes would be our final answer. Then we box that off. So you did your first word problem possibly. Let's now go to another example. All right, our second example, this is for all the health scientists out there. So dosages and medicine is a common thing that you will have to calculate on the go, potentially in your future career. So even if you're not, and you're just interested in chem or just you want to pass the class or any class, we still have to be able to read these problems. So with this one, it says many medications have dosages that depend on weight. The dosage of naproxen is 5 milligrams per kilogram of body weight, 2 times per day. If a 120-pound patient starts with a 6,000 milligram bottle, how many days will the bottle last? Oh, that sounds hard and really scary. So let's look through it. So the first sentence, many medications have a dosage that depend on weight. Great. It's a piece of just information. It doesn't tell you anything. So just something that's useful to know, but not good for this problem. The dosage of naproxen is 5 milligrams per, that word per, right? That's going to come up a lot, kilogram of body weight. I think I'm going to use a different color. Let's see something brighter. 5 milligrams per kilogram. And that says 2 times per day. That is a very complex conversion. So let's write that down. So it says 5 milligrams per kilogram. 5 milligrams per of the drug. So we'll put 5 milligrams of drug per kilogram of body weight. And what we're doing is we're doing that 2 times per day. So we'll put that as like a times 2. And the whole idea with that is this is a unit that you got to mash together and derive for yourself, it looks like. So we're going to have to potentially use this to derive something. So this is going to be a multi-step problem whenever you see something that complex. Now it says that if a 120-pound patient, okay, so that's another big piece of information. So 120 pounds. So let's write that down. 120 pound, and that's for body weight. So there's a conversion term that will cancel eventually. It's body weight and body weight will cancel, but we need to get them in the same units. That's crucial. Let me move that over just a little because it's getting cut off by me. Okay, there we go. Now it says the patient starts with a 6,000 milligram bottle. Okay, so here's another piece. So of the drug. So we have 6,000 milligram of the drug. Okay, how many days will the bottle last? Oof. How many days will the bottle last? So what our desire, so we have a lot of given information, all given. Our desired, on the other end, is just we want to know how many days will the drug last us before we have to refill our prescription. So if we are doing that, well, let's see where to start. There's multiple possibilities here. One thing you'll see is that there's one giant conversion term. The 5 milligrams of the drug per kilogram of body weight is a massive conversion. I would not start with that. Then we have 120 pounds, okay? And then the 600 milligrams of the drug itself, or 6,000, sorry. So one of those two terms we have to start with. Body weight is usually an easier one to start with because then it gets those units canceled. And I think what we'll do is we'll do this in 2 steps. So let's start with body weight. So with this, we have a 120-pound patient, right? So that I'm going to put body above it just so we're familiar with where that weight is coming from. Because notice we have 2 masses. So we need to make sure that the masses that are together stay together in terms of cancellation. We don't want to mix the milligrams with the pounds and kilograms, even though they're all masses, but they're not related to the same thing. So we now got to go from pounds to kilograms. So that way we can use the one conversion term. So we have to look in our handy dandy sheets to see, okay, pounds to kilograms are reference sheets. And you will see that 2.205 pounds is 1 kilogram. So this is something you look up. When we do that, pounds cancels pounds. It puts it in kilogram for ourselves. The next thing that we're going to do is now we can use that big conversion term, which when we combine this, we can essentially figure out how much drug are we taking per day per kilogram. So what I mean by that is let's combine that all together. So if I take 5 milligrams times it by 2, what that will then tell us is that, okay, well, we're taking 10 milligrams of the drug for every 1 kilogram per day. So 1 kilogram of body weight, 1 kg of body weight per day. Okay. So now when that happens, this is a hard one. It's trying to see that. Is a body weight, the kilogram of body weight will cancel the kilogram of body weight. They'll both cancel. And now this leaves us with 10 milligrams of drug per day. So which is what we eventually need to get to days. So let's just solve for this part, and it will define for ourselves a milligram per day conversion term, which is great. That's something will help us figure out the bottle. How long will the bottle last? And that'll be our last little t-table. So what we need to do is 120 divided by 2.205 times 10. And what we will get is 544 milligrams per day is what our patient needs to take. Great. So now, what we will now do is one last step, which is that we'll have 6,000 milligram bottle, and we will convert that using this dosage, which is the 544 milligrams for every day. And that will give us our final answer. So we do 6,000 divided by 544. And what we're going to get is 11.0 days is going to be our final answer. So it's going to last the patient 11 days before they need to either get the prescription refilled, or that will be how long it will last. So this is a harder problem because it took multiple steps. But notice that being that we had two separate terms by themselves, the 6,000 and the 120, I split it up into two problems to make it easier. Try to simplify the problem. If it's something really big and you can't really see how to cancel everything out easily, it could be split into two problems. Just start eliminating a few units and then try to come back together on the next part. The third example will be a little bit easier. I wanted to do one hard one. All right, on to the next problem. So at a local college, the students have been overdosing on caffeine to help them study for exams. Oh no, that's not good. But that did not give us any piece of information that we needed for this problem. It just told us the situation. Meaning many students have been getting sick from drinking too much coffee. It is known that 3 grams of caffeine taking in one day is dangerous. Okay, so right there we have the number 3 grams. So maybe that might be a very important piece of information. So let's highlight it. Now it says how many cups of coffee would be too much and at a dangerous level of 3 grams. Okay, so there's that 3 gram number again. So that's definitely going to be an important piece of information that we need to write down, that we need to know something about 3 grams. That is our limit. So 3 grams of coffee. Now it says a cup of coffee contains 21.5 milligrams of caffeine per ounce. Okay, so that means that we have another conversion term, which is as 21.5 milligrams per ounce. So let's write that down for ourselves too. So we have 21.5 milligrams of caffeine per ounce. Okay, so there's that per term, right? We keep seeing that. So that's one. And then the last thing, it says a cup contains 8 ounces. Oh, great. So it's something we don't have to look up. Is a cup contains 8 ounces. So it tells you how big is a cup of coffee. Cup, and that's 8 ounces. Great. So now when we do this, let's see what our common trend is. So what should we start with? We have 2 fractions, right? So we have 2 conversion terms. We have the 21.5 milligrams and the 1 cup per 8 ounces. We have a term by itself, so we should definitely start with that. That will make our problem easier. However, how do we bridge the gap from coffee, which is grams, or how much? Sorry, it's not even coffee. That's actually caffeine. 3 grams of caffeine. It's not 3 grams of coffee. How would we bridge that gap? Well, being that 2 of these things are both caffeine, we're going to have to go from caffeine to caffeine. That's our key. So we need to go from grams to milligrams. So why don't we define that for ourselves? Now you can look it up in our handy dandy prefix tables, but I will write it down for us. 1 gram is 1,000 milligrams. So we have another conversion term for ourselves. So we can choose whichever one will help us later. So when we start this down, What we're going to start with is the term that is by itself, which is the 3 grams of caffeine. We have 3 grams, and that's caffeine. Then we will we'll convert that to milligrams for ourselves. So what we said was 1 gram is 1,000 mg. And then we see, all right, that canceled out. Great. Now, what we will do is use that conversion term that was up top, right? So the 21.5 milligrams, we're going to use that one there. So when we use that, the 21.5 milligrams will cancel out 2 things here. So look at this just to see for when you do stoichiometry, this is useful. So the milligrams cancels the milligrams. Then the word caffeine will cancel the labeling for caffeine. So that all gets canceled. You can do that where you can cancel it in multiple places as long as it's all top bottom. So keep that in mind. And they do not have to be next to each other. You can cancel across a problem, which is really, really useful skill to know. All right, and that's for every ounce. And I'm going to shorten that for ounce, right? So it's OZ as an ounce. So now the last step for this type of problem is that 8 ounces is per cup. So we have 8 ounces is 1 cup. And let me move all this a little over. So when we do that, right, we'll see that ounces will cancel ounces. Then we'll be left with cups. So we'll multiply everything on top, and then we'll divide by the things on the bottom. So we have 3 times 1,000, it equals, divide by 21.5, it equals, then divide by 8. When you do that, right, this problem has to be in 3 sig figs based on the numbers given to us in the beginning. And what we will get is 17.4 cups of coffee would lead to a student getting sick. That's a lot of coffee. Hopefully you're not drinking that much in a day during your semesters or at work, but 17.4. All right, so that's how you do these hard word problems. With our final takeaways, what we're going to be doing in these different problems is we are always looking for the given pieces of information. We look for sentences with 2 quantities or conversions so we can write down all these little givens. You'll then have to map out how to go from one unit to the other. This might require prefixes. Those are a big hint if you see similar units. Same thing going from US to metric. We might see the same thing. So pay attention to your measurements. Are they all masses? Are they all volumes? Are they lengths? Are they the same? They will help you. If you need to, read the problem slowly to find what you need. Don't feel like if you read it once, you're like, I didn't find it. Go word by word. When I say problems, I say them out loud all the time. Even if you're sitting at your desk, you can say it to yourself just quietly. And if that helps you, do it. Don't worry about the people next to you unless your teacher starts yelling at you. That's different. But if you need to kind of word it to yourself, do it. Help yourself. Let those units guide you in your thinking. Because those common units, they'll all have to cancel, right? Opposites cancel. Look for those. Now, the last tip is don't start with a conversion. That's not all the time. There are exceptions to that. If you were given a problem with only conversion factors, then okay, you have no choice. If that's the case, the hint I can give you is make sure the unit that you desire is on top. Okay, so you want it on top. So that way on the final part of the problem, it's still up there. So you need to just cancel the other units out. So start with whatever you want where it needs to be in the final answer. That makes sense. And if that's something you want to see future videos on, let me know. I can try to make a practice problem video on it. Now, so dimensional analysis is kind of with Bill Nye, right? Ending with that, who's one of the best scientists out there when it comes to teaching all the science. It's right when the units cancel. It is simple as that. That's not a direct quote, but it's all about just canceling the units. Let the units guide you. And I hope this video helped. I will try to make more of these math videos in the future. And please hit that like and subscribe button. Help support the channel, help it grow. It's been growing. And thank you so much for all that support. I will see you all next time. This has been Dr. Dan, and I will see you later.